Hey, what's up guys, my name is Cherno. Welcome back to Code Review series where we take people's code, we review it, we talk about it. We're still on this game about the flying dog situation, but I think that's coming to a close. So chernoreview@gmail.com, email address will be in the description below as well with some instructions. Send in your code, we're gonna use it. We're gonna make an example out of you. I mean, that's what's gonna happen. So for those of you who are brave enough to do that, please do that. I just want to basically today talk about this thing, and I think we're going to be more or less done with this code base. I noticed this last time. So last time, by the way, we talked about like how to write better header files, which is quite subjective, but my opinions on that at least. And we also talked about how to debug the preprocessor so you can see what's going on behind the scenes, how to like track which header files are included where. Quite a lot of useful tips, I think, for those of you who are new to that kind of thing. I'll have that linked up there. Definitely check that out. And I remember noticing all of this code down here, which, you know, when I see like this many vectors of what looks like the same kind of stuff, that immediately jumps out at me, and I think we can talk about how this can be improved. And I have quite a few things to say, I think, about this, because you can see as well that in the actual update like function, which I guess happens somewhere over here, game render, for example, game update, same kind of thing. It's going through like all of these collections here, iterating through all of these collections and doing stuff. And a lot of the stuff that it's doing is pretty much identical, and yet they're split up. And what's even more interesting about this particular implementation is they're not actually different types. They're split up. Well, it looks like they're split up just for the sake of being like, this is the blackbirds, these are the green birds, these are the bluebirds. And it sounds a bit weird, like why would you split them up? But I can kind of see why that's done, because just from this context, it makes no sense. But, you know, what's important when you're code reviewing code and when you're writing code and when you're reading other people's code is context. You need to know the whole story. Like, you need to know more. And I mean, this isn't even purely about context. It's more about like, well, okay, what are the other uses of this kind of thing? And if we scroll down a little bit, you can see that in game collision, there's a different kind of situation that happens. There's different behavior based on what is colliding with what. And so like player versus blackbird, player versus greenbird is presumably different. Now, it's not immediately clear why it's different. I mean, you can see the score number changes differently, and the number of lives, for example, goes down if you hit a blackbird, but if you hit a greenbird, you just lose score, it looks like. You don't actually lose any lives. You know, we spawn, looks like some sparks, probably the same amount of sparks. This set to kill gets triggered. I don't know why this is called val as well. It's a little bit weird. I would just call this bird or something, so it's like very clear what it is, but instead val, which I'm assuming stands for value, is a little bit of an interesting use of language there. Anyway, so down here, if you collide with a bluebird, you get score, right? And all of the time, you can see the amount of code that's duplicated here, right? Like this exact code, you can see it's showing up here. It's being highlighted by Visual Studio. That's the same. This is the same. This is the same. The only thing that changes, or the only two variables we really have here, are basically like the score number and the lives number. So these are the two things that could be somehow parameterized, right? So that basically the same exact thing happens. And by the way, the actual if check that's doing the collision, right, that's obviously going to be identical because it's just like one hitbox versus another hitbox, right? We're colliding two rectangles together. We're seeing if two rectangles overlap is really what we're doing. Like that's obviously going to be generic and the same as well. So my point is, my really big issue with this is not even getting into like the fact that these are all in different collections and this is bad, and we'll talk about why that's bad in a minute, kind of from the computer's point of view, because you can probably see why it's bad from a code point of view. But then also like with the whole collision situation, like, you know, this just really needs to be made to be more generic so that we don't have to repeat this. It could be collapsed into a function really easily as well, which would be very helpful. And really, I think this could actually benefit from being handled a little bit more in the way that like a physics engine would do this, which is basically like you could have a collision callback and you're like, okay, here is object A, here is object B, what do I do? And technically, like down the whole physics engine like kind of path, if this was implemented in a game engine, you know, like Hazel or Unity, then you might actually have written the collision callback on the player class. So you could have like a player entity class, and then you could just have a collision callback there, and then that way you at least know that you're definitely checking the player's collision with something. Like one of those objects is immediately known, because that callback wouldn't be called if it wasn't you, the player, who collided with something. Therefore, you would only ever have to be like, is it a blackbird? Okay, then, subtract this amount of score. Is it the green bird? Then, okay, do this. Is it the blue bird? Do this, right? So you could kind of have that all collapse within that one function. And then if you want it to be even more kind of special, you could just have like a function called like get bird score or something, which could take in like, I don't know, the ID of the object or whatever. That you could even be like, I guess you could be like the type ID of the entity that you've collided with, and then if it's like the blackbird's type ID, like you could have it mapped out basically in a literal map where you just have to look up the type ID to get the score that should be added. And so in this case it would be -50, in this case it would be -30, and in this case it would be just 30, right? Because you're adding it. Lots of different ideas here, all of which I think would be an improvement. So yeah, let's kind of dive in and talk about this in more detail. But first I want to mention that this video is sponsored by Brilliant.org. For those of you who don't know what Brilliant.org is, it's a fantastic website filled with a large number of high quality courses on various STEM topics. They have a great selection of beginner computer science courses that can really help some of you out if you're just taking your first steps to being a programmer. And then, personally, what I love Brilliant for is their catalog of math courses. They have everything from like the beginning, like the everyday math course, which is really simple and will cover some basic math concepts, all the way up to something that would be more useful for even someone like me who has quite a lot of experience. And by that I'm talking about things like calculus, which every now and then I do need a refresher on, and Brilliant is great at that. Why specifically Brilliant? Because all of their courses are extremely engaging and interactive. They present all of their content visually, and on top of that, give you like these widgets that you can play with to see like how the numbers affect the results. This kind of visual way of learning I find is, well, for me, it's the best way to learn. And on top of that, they'll also quiz you after all of these lessons to make sure that you're actually learning what they're teaching you, and that really helps to retain that information. The best thing about Brilliant is you can get started for free. They have a free 30-day trial which you can use to check out everything they have to offer. Brilliant.org/the Cherno is the link for that. It will be in the description below. And if you do go on to like it, Brilliant have been nice enough to offer the first 200 subscribers 20% off an annual membership. Huge thank you to Brilliant, as always, for sponsoring this video. How cool is this coffee cup? All right, let's get back to it. By the way, as I'm scrolling through all of this stuff, like my plan, honestly, for this video is just to kind of talk about what I would do. I realize that on a surface level, like hopefully that's helpful to you guys, but I also realize that it might be better maybe for me to actually physically rewrite this code the way that I would. The reason why I don't tend to do that is because, just talking about it and trying to teach it, that takes up like 40 minutes, right? And then if I try and implement it, that might be another 40 minutes to an hour. And so it's just too much. So I'm just wondering like if that would be something that you guys would like to see in a dedicated video. Maybe even it could be like a Patreon only video. Yeah, I don't know. So let me know like if that would be useful, or if maybe my explanations are more or less like in-depth enough that it makes sense for you guys to do it. Because that's the other thing, right? It's good. I think from like a teacher's point of view, like it's a good thing for me to explain all this for you, and it's almost an exercise for you to try and go and figure it out on your own, rather than having me kind of give the answers to you. Though I guess that would be useful if you're lost, or just to check if you were more or less on the right track. I don't know what I'm doing. All right, so the first thing I want to talk about is why this is not great. So when we iterate through all of these things, you have to remember that there's like, I don't know, I think it's important, and maybe I'm just a little bit too deep in like the low level game engine side of programming, and that's totally okay. These code reviews are really just about me expressing my opinions. Obviously this game runs fine. Like there's nothing really wrong with the way this game runs. I don't think. I didn't really measure the performance, but it was fine. I mean, I do have a pretty beefy computer. Maybe it struggles on some platforms, but that's besides the point. The reason why I'm giving the advice that I give is kind of twofold. First of all, it's because when you scale these projects and when you kind of maybe work in the context of a larger system in a team, or even this game, presumably you want to make something more complicated than this game in your life. And when that happens and you scale these things, some of these kind of programming techniques don't extrapolate particularly well, meaning that if you start scaling them, like if you suddenly make a game and there's 50 different types of birds, like are you really going to have this here, right? It reminds me of something Polymars tweeted actually, like yesterday. Polymars Twitter is just literally filled with just like memes. Yeah, here it is. This was like yesterday. How high did you make your is even function? It's taking forever. And the code is this. So my point is that like I want to like help you so that it avoids situations like this where clearly like something like this, as stupid as it looks, might be okay if you were just doing it for like 4 numbers. Right? Like, of course, there's an easier way to do this. For those of you who don't get it, you would just do mod2 equals 0. That's like what you return. You know, number mod2 equals 0, whatever. That will tell you if it's even or not. And I would still write that to be clear. But if this is all you're dealing with, then it's not really a burden to write that versus this. And maybe you could make a case for the CPU being able to execute this a bit faster. I actually don't know if that would be faster than like a few branches, especially if it happens to be like number 1. Also, what happens if it's 0? I guess it doesn't. I guess there's like an else at the very bottom that just says false or something, but that would be wrong because 0 is, I guess 0 is an even number. Is 0 an even number? This is deep, you know, this is a deeper tweet than I thought it was. But anyway, the point is, like, if this is all you're dealing with, like you're just dealing with this block here, then like, yeah, it might be not the best way to do it, but it works for your case. And at the end of the day, the most important thing, at least to someone who I guess releases software as well, not just like makes it for the fun of programming and then never ships it, as someone who ships software, like the most important thing in my head is like the consumer, right? Like the user. The player of my game, the person who's going to actually like be the client, right? Download this software and run it on their computer. That is the most important thing. The second most important thing is probably like the rest of the team and how they can deal with the code, and if they can like, if it's good for maintenance, if it's good for kind of, you know, building upon, is it easy to read, that kind of stuff. But the most important thing is always like the client. And the reason why I think that's a really important distinction is because code might look very, very beautiful, but it might not perform optimal. And so I guess because the client is number 1 in my mind, I would prioritize performance over code readability. And I think that like that's important. That's what I think. Anyway, all of that aside, the point is you can see how this doesn't quite extrapolate nicely. Like if you need, you know, 10,000, then you're going to have like 10,000 lines of code. And I think he even had a follow-up tweet to this. Follow me for an exclusive discount on my new isEven function featuring over 20 million lines of code. Support for numbers above 20 million coming soon, which is kind of hilarious, I think. So I guess props to Polymars for that tweet. I don't know if he actually came up with this or if he's just like recycling memes, but you know, I won't get into that. So the 50 bird scenario is not going to work. And so I just want to be clear that like that's kind of why, you know, we're talking about this stuff. From like a code point of view, this doesn't extrapolate nicely, it doesn't scale well, but also from like a performance point of view, I do want to mention some things that are going on here. So from a performance point of view, I think one of the most critical things that you can think about that isn't like immediately obvious to people with less experience is memory, and how memory is more important than you might think. And the reason why, see, this is why these videos are so long, I think. It's not because it's because I just talk about, all right, whatever. When people, or should I say less experienced, like beginners, and I'm not saying this in a condescending way, I'm just saying it in like a factual way. Maybe that is condescending. The kind of entry-level way to look at memory is, okay, I have 32 gigs of RAM, so I better make sure that I don't allocate more than that. That's it, right? So if I'm allocating more memory than I need, that's a waste of memory. And so people look at it as just like, this is a resource, you know, you have a finite amount of it, like 32 gigs or whatever on this system. Obviously other applications are using some of that. I can use like 30 gig or whatever. People who have computers that have 8 gigs of RAM, well, I better make sure that if I want them to be able to run it, I better not use more than like maybe like 5 or 6 gig or whatever it may be. That's like the level 1 way of looking at it. The level 2 way of looking at it, or like the rest of your life looking at it, is kind of like, okay, but the way that the memory is laid out and the more memory that there is basically means my CPU runs slower. And that's the really, really, really important takeaway from this. It's not the fact that, okay, I'm going to use more of a resource. It's that my program is going to run slower if I use more of the resource. And a really easy way to look at it is very simple. You have an array with like 1 million elements in it, and you need to iterate through all of them and print them. Is that faster or slower than if you had an array with 1,000 elements that you had to iterate over and print? The 1,000 elements would be faster than 1 million elements. Now, you are obviously just physically doing less work, but that's the point. If you can get your program to function the same way but do less work, it will be faster. And so what I'm getting at is it doesn't matter if you have enough memory for 1 million elements, it's still going to be faster to process process less data. And then, like, I guess the level beyond that is kind of like, okay, well, what about like the location of the memory? What about like fragmentation of memory? What if my CPU starts iterating over a data structure like this, and then suddenly has to jump to another data structure that could be somewhere else in memory? Is that faster or slower than if it just had to iterate through a single data structure? And to that I say, pretend that this is just a off the top of my head analogy, but pretend that you have 3 kitchens in your house with dirty dishes that you have to wash. Once you finish with one kitchen, you have to walk over to the next kitchen and begin your dishwashing process. Once you finish with that one, you have to move on to the next kitchen and do that as well. If someone brought you all the dishes into just a single kitchen, it would be faster, right? Or at least, at the very least, more efficient. And so when I look at all of these collections, there's 2 things in my mind, and again, both of them are from a memory point of view. One of them is immediately, okay, I literally have 1, 2, 3, 4, 5, 6, 7, 8. I guess if you count that, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 different vectors that I have to iterate over, presumably every frame. Those 9 vectors are going to have 9 heap allocations that are going to be in presumably different places in memory. I say presumably because like there is a way to write a vector and there is a way that you can configure this. It's not done here, but you could have it like allocate from some kind of arena allocator where it actually is more or less contiguously in memory, or at least very close by, which would help the CPU prefetching and all of that. But obviously this is just like a bunch of vectors, and they're not really, nothing complex is going on here. It's just at face value what you see, 9 blocks of memory. Now, the next part of the indirection is the fact that these are all unique pointers. Now, they more or less have to be. I actually thought they had to be more than they did, but like there's quite a decent chunk of data actually in here. That's like step 1. I did think they were all kind of subclasses, so I thought there was an actual class hierarchy here, but there's really not, from what I can see. Like none of these are subclasses of anything else, which is I'm sure a lot of you would say that's a good thing. I mean, Sparks is okay, a subclass of explosion. A lot of you would probably say that's a good thing. All of you OOP haters out there, I would say that this could benefit from having some inheritance, because this is clearly not set up to be a component-based system. And we can talk about like, an entity component kind of system situation as well. There's really infinite stuff to talk about, but let's just start with this. So the fact that they are unique pointers, that's okay. What that basically means is that somewhere in your memory, right, you have this, for example, this is the background little static object. Let's just go with the birds because they're more fun to visualize. We have like the blackbirds, right? And what that is it's not actually the blackbirds, right? The blackbirds meaning like their positions in like in the world, in like the map or whatever, their like velocity where they're traveling, like this, which sprite to use for them, whatever. It's not that. What it is instead is a pointer. So what we're seeing here is kind of just a collection of pointers, right? And then that means that as we iterate through the blackbirds, so the step 1 is to be like, all right, I'm writing a for loop. I'm iterating through this blackbird data structure. So step 1 is I'm going to, the CPU, is going to be like, all right, well, I need to iterate through this. So let me just grab like some memory to start iterating over it. And it being the CPU is going to prefetch more than just that byte of memory or that like 1 element's worth of memory. It's going to prefetch a bunch more, which is important. Then what's going to happen is it's going to be like, all right, well, this is actually a pointer. So I'm going to read the contents of that pointer because that's the memory address of where I need to go next. And then I'm going to reach out and grab the actual location of my bird. I'm going to go to the location of this bird as dictated by this pointer, and those are the bytes, the data that I need to read. So I'm going to grab that as well. Then I'm going to go back and read the next bird, which is going to be in a different position in memory. And this one's over here or whatever. Now, again, realistically, if you allocate stuff more or less one after the other, it is kind of likely to be in a similar place in memory. So like when I draw these lines, one going that way, one going that way, it's not like it's completely random. It usually isn't, especially because the kind of heap space that you get allocated for your application is more or less like, the heap can grow, but it's more or less like the operating system will try and give you something that's kind of contiguous-ish. Like it's not going to deliberately try to make everything run slowly. But it's still obviously not guaranteed, which is why we're kind of going by those rules. Anyway, so that's kind of you going through all of this. Now, this is still better though. Having like a contiguous block of pointers, even though you do have to go one step further to get the data from them, that's still better than basically having like, 1, 2, 3 of them here, and then having like another vector somewhere else in memory that has the next 3 birds because you've decided to separate your black and green birds, right? So you have that kind of segregation going on, and you got like, you suddenly have to jump to this next vector to get the next 3 birds. And you can see that after that, it's like the next one, and then the fireballs, and then the buildings. If they were all at least in one kind of collection, then, you know, there'd be like one less kind of indirect step to get. And also all of these pointers, all of these locations of every element of data we need would kind of be all contiguous at least. And so that's still kind of better. So I guess my point is, when I look at something like this, you know, from a code point of view, it's immediately clear that like this isn't gonna scale if I add 50 different bird types. But also from a performance point of view, and from like the computer's point of view, I'm seeing like obviously each one of these is kind of a different place in memory, and then also this is a memory indirection, because this is just really a pointer to the actual block of data. And so I'm kind of picturing the CPU having to iterate through all of these guys, and it's like that's, you know, a cache miss, that's a cache miss, that's a cache miss, that's a cache miss. They're all kind of cache misses, which essentially just means that there might be a higher cost to actually getting the memory we care about so that we can iterate over it, because it's not already in the CPU cache. And to be honest, like there are tools that can actually tell you, like Valgrind comes to mind obviously, but I actually haven't, I don't think I've used any tools on Windows that do this. I'm sure that maybe Microsoft probably has something kind of like address sanitizer, but a little bit different maybe. There are tools that you can use to actually literally measure how many cache hits and misses you have. So this isn't all arbitrary. Like you can actually find out, and that's why like I'm really thinking that rewriting some of this code might be useful, because then we can kind of compare the before and after. But anyway, long story short, you can see all of these are practically the same. Like they all do val update. If the update functions were different from blackbirds to greenbirds, I would probably use inheritance here to make a base bird class and then have a subclass called blackbird, greenbird, bluebird that had a custom update function. That would be totally fine, and that would kind of help you collapse them. In this case, they are the same, and again, they are the same, and they're all birds, right? There's only one type of bird here. They're all birds, but they're split up because they need to be for other things. But if you look at something like, you know, the static background, for example, right? So here it is, background, right? This is a static object. Like, I feel like you could probably have a superclass called object that has, because look, I mean, you know, some of these things are kill enabled. I guess that's whether or not you should destroy it next frame. But like, you know, all of this kind of stuff, I'm sure this applies to birds as well, you know? I'm also not sure why you're maintaining both of these things, because this looks like it's just made up of that. And then the hitbox presumably is also similar to that. But anyway, you know, you could kind of have, yeah, like you can see there's a lot of functionality here that really is duplicated. And so I would kind of organize this a little bit more so that you have all of your common things in one object. Then you can have just a kind of a vector of all of those specific objects. The other thing that you're doing here is like you're keeping track of individual objects as unique pointers here instead of having them in a collection. And that means that if you want to draw stuff like this, instead of it already being in a for loop so that you can draw it, you have to call it by its variable name specifically because it's not part of a collection. And if you want to destroy it, you'll have to also do it by name. So that's also unnecessary. What I would do is, again, I would ultimately, the way I would rewrite this is I would just have one collection that would basically be like of base class object or something that was just like all of my entities, right? Or all of my objects. They're all in here. And then if I wanted to, I could have some kind of like weak ref or whatever. Like you could literally just have, I guess, a static object pointer or something of that. But the key here is that would point to something inside the vector. Now that itself is really dangerous to do because if the vector ever reallocates, this pointer is now lost, right? So that's probably not the best way to do it. And that's why at the end of the day, like in, I guess, more complicated systems, you might have like an actual map and every entity could have like a UUID or some kind of identifier. And then you could just look up the map to get that object's data by its ID. But that's more or less how I would do that part. When it comes down to all of the physics collisions, the way I would rewrite these is, well, first of all, straight up, this should just be a utility function, right? Like this should just be one object versus the other. Let me know if they overlap, if they collide, right? The reason I guess it's not like this is because I mean, here, these could all easily be collapsed, right? Like literally in 2 seconds, I can just make a little namespace called utils even if I wanted it to be like a utility class, static bool, you know, collides. You know, we could take in like a player, And we could take in this bird, presumably, and then we could just return that, right? Like that's done in like 2 seconds, and then suddenly that means that we just need to do player and val inside that like utilities function or whatever. Now, player is a unique pointer. One thing you could do as well is you could just make this be unique pointer reference, a const one, because you can't copy unique pointers, of course. Get rid of this last parenthesis. Yeah, and that's kind of it, right? So this just immediately gets, you can see how much that kind of collapses this code, which is nice, makes it a lot more readable. The reason why it also makes it readable, I think, which is really important, is because, like, you know, it's pretty obvious to someone who's been around the block a few times what this is doing, right? Like, we're comparing, like, hitbox things, and that plus that, is that greater than that? Like, you know, obviously, I can tell that this is two AABBs or two hitboxes, two rectangles, whatever, and we're just checking to see if any kind of corner of them overlaps. That's what's going on with this code here. That's easy to read to someone who knows what that looks like and who has done it before. Now, this is easier to read, though. Utils collides, right? So, like, you know, if collides player and this bird, right, which again, I would rename val to bird, I already said that, but if collides player bird, then do this. Like, that just makes sense more in English, and it's a lot, I think, better to read objectively, you know, than this code here. So that's why, like, you know, I think that's something that you should always think about, is not only can I save code duplication here a billion times, but also, like, what does the code actually read like when it's done? Right? And this would just be a lot kind of easier to read. And you can see that it's literally like 4 times I think I've replaced this. So it really was just the same code over and over again. Now this actually though is player building. That's where things change. And that's why you can see that what was going on here was the same thing. It was still get hitbox. Because this kind of get hitbox is present in basically everywhere. Like if I search for this, you can see we've got it in bird, we've got it in fireball, we've got it in player, we've got it in static object, and that again is why it would be so nice to just set up a bit of an inheritance hierarchy here with the common functions. Some people will say that's bad. I honestly don't see the problem here. And if you want to argue about like the V table and indirection, like I guarantee that's not going to show up in any profiles or have any problems with this specific use case. And from a code point of view, it obviously makes it a lot easier. Now, the last thing that I want to talk about, because I think you guys kind of get the point with this, and I could go through and rewrite all of this, but you know that would take a lot of time, and hopefully what I've said is kind of clear enough. The last point of view would be like, what if this wasn't, because there's kind of 2 ways you could go about this. You could put all of your common functionality into like a base class, you know, that would be like your object class or your entity class, and then you could derive from that for things like the player, the birds, the fireballs, whatever. That's kind of the inheritance approach, and that's kind of like the more old school approach. The newer school approach, the kind of modern approach, is more data oriented, and that is through an entity component system. And the reason why that is better is because you can see that if I want to go through and, for example, you know, check the physics or, you know, move one of these objects or whatever, what I'm kind of doing is I'm iterating through every single bird, right, which is going to have a different location in memory. And then I'm going through and I'm trying to kind of get all of its data and move it. But I don't need all of the data that's in the bird. For example, if I'm just simulating physics, I kind of just need like that hitbox, right? The bounding box. Maybe like its position as well in world space. That's all I really need. I don't need information about like, is it dead? Is it like, what sprite do I use to render it? Should there be some kind of piece of audio that is playing? And what's the pointer to the audio like data or whatever, right? I don't need any of that. However, I've got all of that because when the CPU looks up this bird and gets you that memory, it doesn't just get you what you need, it prefetches obviously a bunch more. And so you have all of this memory that you never end up using. So a more data-oriented approach would be, okay, well, why don't we bundle up, like, say we need to go through and like just move every bird by its velocity, right? What if we just had the position and the velocity of every bird like that in one little package here, and then we had a collection of that. So position and velocity of the next bird. So this is bird 0, bird 1, bird 2. If I iterate through a vector of these guys, especially if they're not pointers and they're just kind of, you know, in the actual memory, because they're just going to be like 2vec3s or 2vec2s or whatever, that would obviously be a really nice scenario, because all of this that's here is all contiguous in memory. It's all very cache friendly, and I don't have to kind of look up this bird, get a bunch of memory that I don't care about, and discard half of it, and just use, like, you know, 2vec2s, we'll say, as a 2D game. So like 16 bytes of it for these 2vec2s, just use that portion and then discard all the rest of the bird information, because that's not useful to me. That would obviously be a better approach than any of this, but it's also a little bit harder to set up an entity component system. You can use something like entity, ENTT. That's what we use in Hazel for our entity component system. It's really good, performs really well, fairly easy to use. Like, it'd still probably be easier to set it up like this, not to mention you wouldn't need any libraries. But what it does enable you to do is kind of also forget about the kind of different nature of all of these entities. So what I mean is, at the moment, we obviously have, like, even if we do make a base class called object, we have all of these different classes, and the reason why they're different is because they have different attributes to it. So the idea of having an entity component system is that obviously you have components, and you can use them to compose these objects. And so what that means is that, like, all of the things that these have in common, for example, they have a position in the world, and maybe the static objects don't have a velocity, but, like, you know, birds or whatever might. All of these probably have like some kind of physics bounding box as well. You could just simply add those components to each of these entities. And so the idea is you have like these building blocks that you use to build up all of these different entities, rather than having to write everything in like a static kind of class. You just instead write all of your components separately, and then kind of like Lego, just put the ones you want onto the entities that you want, and you end up with this kind of really cool system of just flexible objects that you can just pile on different components onto. But again, it retains that data-oriented aspect of I can loop through just the parts that I need, and the systems, like the physics systems, they don't have to worry about all the other functionality that might be present in that entity. They only care about the data that they need to care about, and that improves performance. So that could be another interesting exercise, taking something like this through a few levels, and maybe making it first the inheritance-based approach, then maybe like a data-oriented approach, and like with an entity component system. That could be a really good exercise for you guys as well. The code, like this code, is linked in the description below. Hope this person who sent it in doesn't mind us using it as an example, but I guess that's the point of this series. I honestly would do something like that. If there's enough interest for this, I might do it, and if I have enough time. Maybe it will be useful to show like the conversion of something like this into various different systems, and also maybe we could measure performance or CPU cache hits and misses, that kind of stuff. But other than that, I hope you guys enjoyed this video. If you did, please don't forget to hit the like button. Don't forget to check out brilliant.org/thecherno. Link will be in the description below. Send in your code to chernoreview@gmail.com, and I will see you next time. Goodbye.